our next topic for 4.4 is to be able to handle some indeterminate forms that are not directly 0 over 0 or plus or minus infinity over infinity. So for this next ones, our goal is to do some algebra to get an indeterminate form for which we can use L'Hopital's rule successfully. And so one of these forms we're going to talk about is 0 times positive or negative infinity. So this is indeterminate because it could either be 0, positive, negative infinity, or they're duking it out and they end up at some constant in between. So the goal here, we cannot use L'Hopital's rule directly, but you try to put it in a form so that you can. So the first thing is write as a fraction. And so it's either going to be done by raising the f or the g to a negative 1 power and then also putting it in the denominator of that fraction. So it means the equivalent thing. It's just a way of writing as a fraction. Then try to take the limit, and if you get the form 0 over 0 or plus or minus infinity over infinity, you can use L'Hopital's rule. So just a tip here that there's usually one way that's better than the other, and just kind of as a rule of thumb, usually the more complicated functions that you have with that arrangement of putting one in the denominator and raising it to negative 1 power is going to be the one that usually doesn't work. To just kind of give you a tip there. So try to keep it as simple as possible. The functions on the top and the bottom as simple as possible, but still writing it as a fraction. And then that's usually the way that's going to work the best. Alright, so example 3 is evaluate the limit as x goes to infinity of e to the negative x times the square root of x. So first we try to evaluate this limit directly, and note that as x goes to infinity, for the e part, we're going to have e to the negative infinity. E to the negative infinity, if I wanted to, again, I could think of the graph of like e to the x, and what e to the negative infinity would correspond to is the end behavior of the graph of e to the x, which goes to 0. And then we have the limit as x goes to infinity of the square root of x, that goes to infinity. And if I wanted to play the graph game with that, I would do something like that. Looking at the end behavior as x goes to infinity. The reason why I got switched in this one is because I was looking at the limit of e to the negative infinity, which I could think of e as x as easier to graph and then use that to determine what e to the negative infinity is doing. Alright. So what we have here is 0 times infinity, which is indeterminate form. So one thing we can do is write this as a fraction. This one's pretty obvious on a way to get started. E to the negative x, that could just be pushed down to the denominator and made e to the x. And that's a simple thing to do. It makes the fraction on the top, or makes each function on the top and the bottom simple with my guidelines above. If I were to force the square root of x down, I would have two negative exponents, and they'd be composite functions. They're kind of a little more complicated, and derivatives would be more complicated. So, let's explore this first and see if it works. Well, kind of jumped ahead of myself. What is this limit? Try to evaluate it. You get infinity over infinity. So it's indeterminate, but you can use L'Hopital's rule. So I'm going to do it. Right, then I'm doing L'Hopital's rule. So the limit as x goes to infinity of 1/2 x to negative 1/2 after I take the derivative on the top. Take the derivative on the bottom and just get u to the x. So doing this one, what is this limit on top is a little bit harder to take, but remember the negative exponent. I can think of this thing as being 1/2 times 1 over square root of x. So what this is doing is it's going to 0. E to the x is going to infinity. So actually 0 over infinity is a determinate form. And what you get there is 0. To explain that a little bit better, you could do some algebra first. So if you can do it from there, that's fine, but let me just take what we had and actually do kind of what I had written up there with turning the negative exponents to positive and pushing that function down low. But let's write it all together. So I could do some algebra to simplify this by taking, we have a 2 that can go in the denominator times e to the x, and then also we have the square root of x that could come down here, just a 1 on top. So another way to look at this is now taking this limit of the function written in this form, I have 2 things in the denominator going to infinity. Infinity times 2 is going to infinity. So overall we have 1 over infinity, which goes to 0. And that explains why 0 over infinity is a determinate form. If we had done the algebra, it's like putting something in the denominator. Let me say that again. So something on top that is a fraction is going to, it's like it's going to 0 on top is like 0 times 0 overall if we pull out that 1 over e to the x. So anyway, it is 0 for an answer.